So today we are going to go over how to factor a quadratic trinomial when that leading coefficient is not 1. And it is a little trickier than doing that little x method that we did on the last lesson. We will still use that sort of that x game where you find two numbers that multiply to this and that. That's still something that we will do, but we're going to use it in a different way. And I do want to warn you, like, factoring these are a little harder, and because the TSI2 is multiple choice, there are ways around like going through this process, but I do want to show you sort of the proper way of factoring this. Now, when I say proper, there are a lot of different ways you can factor, but I want to show you, like, if you want to, like, not, I hate the way we use a cheat your way through the problem, but if you want to not have to rely on using the answer choices to figure out your answer, if you want to just know how to do it, I'll show you at least one way how we can factor these trinomials. So when that leading coefficient is not 1, in other words, when you have a number, like all these trinomials are going to be in the form ax squared plus bx plus c. And when I say the leading coefficient, what I'm talking about is that number in front of the x squared. And in the last lesson, that number was always 1. And so when that number is 1, it turns into one of these sort of what I'll call easy factoring problems, where you just find two numbers that multiply to give you the constant and add up to that linear coefficient, the b, and those are going to be the two numbers that go in your parentheses. And I think we're good on that. I mean, most of y'all did pretty good on that quiz. When that number is not 1, though, and all the ones we're going to work on today don't have 1, those kind of problems are going to fall into one of two categories. The first category is you can actually factor out a GCF sometimes and turn these quadratic trinomials into ones where they actually have a leading coefficient of 1. Like, for example, this first one, 5x squared plus 15x plus 10. The leading coefficient is 5. But what we can do on a question like this is actually factor out a 5 as a greatest common factor and make the factoring go a little easier. So if let's find the GCF here. The three terms here are 5x squared, 15x, and 10. So what's the largest number that all of those are divisible by? Yeah, 5. So we can divide out the 5 as a GCF and be left with x squared plus 3x plus 2 on the inside of the parentheses. And now that quadratic trinomial on the inside of the parentheses has a leading coefficient of 1. Still have that factor of 5 kind of hanging out. But these are sort of, like I call the easy factoring problems. Excuse me. So just like we did in the last lesson, we're going to try to find two numbers that in this case multiply to give me 2 and add up to give me 3. All right, 2 being the constant and 3 being the linear coefficient. So what are those two numbers? What two numbers multiply to give me 2 but add up to 3? Yeah, very good. Yeah, 2 and 1. So I'm going to just write 2 and 1 here to kind of help me out. Those are the two sort of special numbers that I'm working with. And when you have one of these trinomials where the leading coefficient is 1, that's really all you need. Okay, still have that 5 hanging out, but the two remaining factors would be x plus 2 and x plus 1. And this is what you sort of hope to happen, is having that GCF to help with the factoring process. But you won't always be so lucky. Sometimes there isn't a GCF for you to factor out. Sometimes it's just 1. And so those are going to be the problems that we're going to focus on today, because I think this is totally doable. I think everyone can handle this one. It's these quadratics like the ones down here where, you got 2, 11, and 12. There's not a common factor there, right? Like 11 is prime. So right away, we know unless they're all divisible by 11, we can't do anything as far as factoring a GCF is concerned. So instead, we are going to factor it using a different method. Now, in the notes here, and initially, I thought I was going to teach this using the factoring by grouping technique. But I've had a little change of heart, and I'm not going to show you that method. I'm going to show you a different method. Okay, and this method is called the Xbox method, and it has nothing to do with video games, so sorry. but that's okay. It's almost as fun. Yeah. All right. So here's how the Xbox method works. Basically, what we're going to try to do is use the classic box method that you would use like if you're multiplying two binomials, but we're going to use it in reverse. Okay. And so let's start by drawing that box. We're going to make a 2x2 box. And this is like in the previous couple of lessons, we talked about an area model to represent the factors. That's what we're constructing here, is that area model. And our answer for the two factors are going to be found along the top and down the side. Okay, when I was talking about before about kind of doing the box method in reverse, what I mean is like usually you use this box method or this area model when you're multiplying things, and I'm going to erase all this, but let's say I'm multiplying x plus 2 times x plus 3. One way to multiply those together with that area model is to set up this 2x2 box. And again, I'm going to erase all this, but you put like x plus 2 up here, x plus 3 down here, and then you do all your multiplications. You don't need to write any of this down. And then the answer or the product would be x squared plus 5x plus 6, right? So that's how we usually use that box. But what I want to do is show you how we can take advantage of that and work it backwards. So let me go ahead and erase all this. All right, so here we go. Here's the Xbox method. We'll start with the box. The very first term, the 2x squared, that's going to go in the top left box. All right, simple enough. The last term, the constant, is going to go in the bottom right box. And then as far as the bottom left and the top right, those are going to be your linear terms, the ones that just have x. And we need to come up with two terms that add up to 11x. Now there are a lot, and by a lot I mean infinitely many, different combinations of terms that could add up to 11x. Right? You could have like 1x plus 10x, or 5x plus 6x. But there's only going to be one combination that's going to work so that we get the correct factors. And to come up with that combination, we are going to go back to that big X. Okay, but we're going to use it a little differently. Okay, we're still going to play that game of like finding two numbers that multiply to this and add to that. But the two numbers that you're going to multiply by or multiply to is going to be the product of the first and the last term. So the 2 and the 12. Okay, so there's going to be like the A times C. All right, so 2 times 12, I'll just write that up here. 2 times 12 is 24. So I'm going to put 24 here. And then the number that you're trying to find the sum for will be that middle term, right? That's kind of our whole goal here, is to find two terms that add up to 11x. And so here we go. So we've got this set up, and we're still like playing the same kind of game here. We're finding two numbers that multiply to 24 and add up to 11. It's just that those numbers in this context is not going to give you the answer directly like it did with the easy ones. So yeah, what are two numbers that multiply to give me 24 and add up to 11? Can you think of it, two numbers? 8 and 3. 8 plus 3 is 11. 8 times 3 is 24. So those are going to be kind of my special two numbers here, 8 and 3. And those will be the coefficients for the two linear terms that are going to add up to 11x. So it doesn't really matter which of those two boxes goes, you can put 8x here and 3x here. It doesn't really matter which one goes where. I'm just going to kind of go in the order that I found them. So 8x and 3x. So now we're going to work backwards to come up with the two factors that must multiply to give me all that area in there. And so the way that you find those factors, the way you're going to work backwards is to kind of go back to our first lesson and factor out the GCF out of each column and each row. So let's start with an easy one. Or the easiest one, I should say. I don't know easy, but easiest one is probably going to be this column. Okay, so we're just looking at that column. What's the GCF between 3x and 12? What number divides both of those evenly? 3. So that GCF of 3, we're going to write that up here, plus 3. That means that one of our factors, which is going to be like right here, is going to be something plus 3. Okay. The other factor is going to be found like going down the side. I erased all that just to clean up the clutter here. All right. Now let's go back and let's finish off that factor and find the GCF of the first column. So be careful here because both terms have an x. So what is the GCF of that first column? Let's start with just look at the coefficients first. What number divides both 2 and 8? 2, right? And since both terms have an x, we can also factor out an x along with that GCF. So the GCF is 2x. And so that's one of your factors, 2x. Or 2x plus 3. Now we're going to do that same thing, but looking at the the rows, not the columns. We already did the columns. So I'm going to look at let's start with the easier one, which I always find is like the constant. So right here, I'm looking for the GCF of 8x and 12. I think that is 4. Yeah. So the GCF is 4. I'm going to put that here. So I know it's going to be like a plus 4. And now we need to find the GCF of the top row. Now 2 and 3 are both prime. So the leading coefficient of that GCF is just 1. That's the only thing that divides both of those. And they both have an x. So the GCF of that top row is just 1x, or just x. So x plus 4 times 2x plus 3 is my answer. Those are the factors of the trinomial. I know this is a little bit more involved than the other one. I still think it's pretty approachable. The hardest thing, I think, is finding those GCFs. Now, you can always check to see if you're doing this right by just multiplying them together. Check the area model and see if it all makes sense. Like, for instance, 2x times x. Does that equal 2x squared? Sure, yeah. 3 times x equals 3x. That checks out as well. 2x times 4 is 8x. That works. And 3 times 4 is 12. So, you could check each one of those multiplications just to make sure everything kind of falls into place. And if everything seems to check out, you did it right. Any questions so far? All right, well, this is just going to take some practice. I mean, that's the process. Now we just have to do it a few times to kind of get in a rhythm. All right, so let's start with the next one. 4x squared plus 13x plus 3. And we're going to use the X-box method. All right, really kind of grown to like this method more than the factoring by grouping because, I don't know, I just feel like the factoring by grouping is just there's too many steps. And I feel like this is a little bit more straightforward. So to get it started, I'm just thinking what I want to do when I get home is play some Xbox. Yeah. I just set up my Xbox. Yeah. All right. I just got to wait for it to turn on. Okay. All right. Now to get this all set up, the first term goes in the top left, 4x squared. The last term goes in the bottom right. And to fill in those other two boxes, I'm going to use my big X to help me with that. The number that I'm trying to multiply by is going to be 4 times 3, which is 12. And the number that I'm trying to add to is just that middle term, 13. So I need two numbers that multiply to give me 12, but add up to 13. And sometimes this is one of the trickiest ones I think of, because how could it add to something bigger than it's multiplying by? I don't know. Give it a thought for a second. Can you come up with two numbers that multiply to give you 12 but add up to 13? Twelve and 1. If you ever see this scenario play out where the sum is just one more than the product, usually that means that it's going to be that number times 1. All right. So, yeah, we've got 12 and 1 are our two special numbers here. So that means in those two other boxes, and it doesn't matter which one goes where, you'll get the right answer as long as you're doing it correctly. So I could put 12x here, 1x here, or I could flip those, but I'll still get the right answer. And now I'm just going to go through each column and each row and find the GCFs. So the GCF of that first column, thank you, we've got 4x squared and 12x. The GCF there is 4x. Right? Both 4 and 12 are divisible by 4, and they both have an x. In that right column, I've got x and I've got 3. Really nothing in common, right? The only real thing you could divide both by is just 1. Now, 1 is always going to be a factor, but that's it. There's nothing really you can divide out of each of those. So it's just going to be plus 1. Now I'm going to look at the rows, going across, and find the GCF of each row. For that first row, the GCF is x. For the second row, the GCF is 3. So I'm going to just put a little plus 3 there. So now I've got my two factors, 4x plus 1 and x plus 3. Any questions about that one? All right. Well, like I said, this just is going to take some practice, and we're just going to do a few examples to really just kind of get in the swing of things. Okay, so let's factor the next one. I'm going to set up my X box here. Put 3x squared in the top left, 2 in the bottom right. The number that's going to go on top of my x is going to be the product of 3 and 2. So 3 times 2, that's 6. So that's the number we're trying to multiply to. And the number we're trying to add to here is negative 7. So if I'm multiplying to a positive number, but adding to a negative number, that means both numbers have to be negative. So here, the combination would be negative 6 and negative 1. Those two numbers multiply to give you positive 6 and add up to negative 7. So the two numbers in those two boxes need to be negative 6x and negative 1x. Now, one thing I'll throw out there is that as you're trying to factor out a GCF, if that leading term is positive, factor out the negative along with it. Okay. So let's go through each of these columns, each of our rows, and see if we can't get our two binomial factors. Start with the first column. Okay, I got 3x squared minus 6x. The GCF is 3x. Both of these are divisible by 3, and they each have an x. For the second row, the second column, negative x and 2, if that leading term has a negative in it, so in this case, negative x, factor out a negative number as a GCF. So in here, the GCF will just be negative 1. When we look at the rows, the GCF of that first row is just going to be x. And the GCF of the second row, -2. Again, I'm pulling out a -2 versus just 2 because that first term is negative. I'm trying to make that positive. And we could check each of these. I don't know if we need to go through all these, but 3x times x is 3x squared. -1 times x is -x. 3x times -2 is -6x. And -1 times -2 is +2. Everything seems to check out here. So our answer is 3x minus 1 times x minus 2. Any questions so far? Feeling okay about this? I know this is kind of hard. The hardest part, I think, is coming up with those GCFs. All right, just a couple more examples for you here. Let me try to maybe refresh this. All right, so we've got 2x squared minus 5x minus 7. Set up my x. Set up my box. And that box is really an area model, is sort of like a better way to refer to it, I think. But yeah, we'll get our box set up. 2x squared minus 7. Looking for two terms that add up to -5x. That means one of them is probably negative, if not both. So let's see what we're trying to multiply to. 2 times -7 is -14. And then we're going to try to add to -5. So this was a little trickier just because we're multiplying to a negative number and adding to a negative. Now, anytime you're multiplying to a negative, it can be a little harder to come up with those two numbers. We do want the difference to be -5 or 5, I guess. One number's got to be positive, one number's got to be negative. But maybe it'd be worth listing out the factors of 14. We haven't really done that. 1 times 14. 2 times 7, I guess that's pretty much it as far as factors of 14. And if one of them's got to be negative, hopefully you can see what the combination is going to be. It's going to be 2 and -7. So 2x, -7x. And now we'll go through, just do the same thing we've been doing, finding those GCFs. GCF of that first column is 2x. GCF of the second column, -7. Again, when that linear term is negative, you want to pull out that negative. And then going down each row, each row. The first GCF is just x, right? 2 and 7 do not share a factor other than 1. And we have basically the same setup on the next row, so this is going to be +1. All right, so there you go. Here's our two factors. I guess I can erase this just to clean it up a little bit. 2x minus 7 and x plus 1. Now, I will say, on the TSI, this is going to be a multiple choice question, right? So the question is going to be posed as here's a trinomial, and then there'll be 4 answer choices that are all factored. I want you to know that, let's say you forget how to do this whole process, you can still work backwards from the answer choices. Let's say this was choice A, and then just try to multiply out each set. So in other words, if this is choice A, if I want to know if that's the same, just set up your area model with 2x minus 7 and x plus 1 and multiply it together. And what you're going to see is that if we combine our like terms here, we get 2x squared minus 5x minus 7, which is what the original problem was. So I just want you to kind of go into that test understanding that, hey, if I don't remember how to factor, you can still get this one right. You just work backwards from the answer choices. All right, last one. And then after lunch, we'll just work on the homework and the IXLs. Okay, so one little trick here is if that leading term is negative, just like in the box method itself, these problems are a lot easier to do if the leading term is positive. So what I would recommend here is actually factor out a -1 up front. So here, like as a GCF, we're going to factor out a -1, which leaves me with 4x squared plus 8x minus 5. And I guarantee you this is going to be you'll have an easier time trying to factor that versus having that leading term be a -1. Okay, so you're going to do that anytime that first term is negative. All right, so now we'll set up the box, the X box, really just focusing in on what's inside the parentheses here. All right, that -1 is going to be a factor. So like when we write our answer, you'll have a -1 here, times the two binomials. So your answer is going to look something like that. But we're really just trying to factor that 4x squared plus 8x minus 5. So here's my x, here's my box. I'll put 4x squared in the top left, -5 in the bottom right. Now we need to find two terms that multiply to give me 4 times -5, that's -20, and add up to 8, that middle term. And if you're having trouble coming up with those two numbers, just start listing factors of 20, right? 1 times 20, 2 times 10, 4 times 5. And if the product is negative, that means one of the numbers has to be negative. So in order to make this add up to 8, with one of the numbers being negative, the only combination that's going to work here is 2 and 10, with the 2 being the negative one. So yeah, my two numbers here are going to be -2 and 10. So I'll have -2x and 10x. And now I need to find the GCFs of each row and each column. So with that first column, the GCF is 2x, right? Both 4 and 2 are divisible by 2. They each have an x. The GCF of the second column is just 5. So I have 2x plus 5. That's one of my factors. I'll just erase the clutter here. A little scratch work. And now we'll find the GCFs of each row. So the first row would be 2x. And 2 and 5 don't really share a factor, but since that leading term is negative, we're going to pull out that negative, just like we do every time. So -1. And it's always a good idea to kind of check to see if these work. 2x times 2x is 4x squared. 5 times 2x is 10x. And you can always do this check and make sure you're doing it right. 2x and -1 is -2x. 5 times -1 is -5. If you find that like one of the multiplications is not giving you what's inside the box, then you made a mistake somewhere. You just want to go back and try to figure out what happened. So that's pretty much it. This is how you factor a trinomial. I don't want to say this is the way, but this is one way how you can factor a trinomial is with this Xbox method.